45,000 years ago, walking across the Australian plains would feel like stepping onto an alien planet. The grazers moved in herds, but they were SUV-sized mammals with trunks. The apex predators dropped from trees, but they were oversized possums with bolt-cutter teeth. The monitor lizards were the size of cars and killed with venom. This was Earth's most successful evolutionary experiment gone rogue, where familiar ecological roles were filled by impossibly strange creatures that had never existed anywhere else. For millions of years, isolation had allowed nature to break its own rules, creating a cast of giants so bizarre they challenge everything we think we know about how life should work. Australia tore away from the supercontinent Gondwana and began drifting north like a massive biological arc. This separation wasn't gradual, it was geological violence that severed evolutionary connections overnight. The continent carried with it a cargo of ancient life forms, marsupials, monotremes, and reptiles that elsewhere would soon face extinction from the rise of placental mammals. But Australia's passengers never met that competition. While the rest of the world was filled with cats, bears, elephants, and horses, Australia's marsupials had the entire continent to themselves. They radiated into every conceivable ecological niche, becoming the grazers, the browsers, the burrowers, and most remarkably, the apex predators. Evolution had been handed a blank canvas and 45 million years to experiment. The Pleistocene epoch, beginning 2.6 million years ago, transformed this isolated laboratory into something even stranger. The Ice Ages didn't bring massive glaciers to Australia, but they brought something equally dramatic: progressive drying. Lush rainforests shrank to scattered refuges, while vast stretches of sclerophyll forests and arid grasslands expanded across the continent. The plants grew tougher, with hard leaves and defensive chemistry. Water sources became seasonal, scattered, and unreliable. These environmental pressures sculpted the megafauna into forms that could survive on vegetation that would poison most mammals and travel vast distances between waterholes. Size became an advantage. Larger animals could store more water, generate their own heat, and defend better territories. The stage was set for giants, but not the kind that had ever existed before. By 50,000 years ago, Australia had become a functioning alien world. Its herbivores were marsupials the size of rhinos. Its predators were reptiles that could kill with venom, and marsupials with teeth like industrial shears. Walking through this landscape would require recalibrating every survival instinct, because the rules that governed life everywhere else simply didn't apply. In the eucalyptus woodlands of Pleistocene Australia, death waited in the trees. Thylacoleo carnifex measured 2 meters from nose to tail and weighed up to 160 kilograms, but its true horror lay in its evolutionary history. This apex predator was a wombatiform. Its closest living relatives are wombats and koalas. Nature had taken the marsupial equivalent of a teddy bear and transformed it into a killing machine. The first sign of Thylacoleo's presence would be the scratches. Cave walls at Naracoorte show deep gouges where these predators sharpened their claws, evidence that Thylacoleo could climb with the agility of a giant cat. It preferred to hunt from above, positioning itself on sturdy branches before dropping onto unsuspecting prey below. Its skull housed the most powerful bite of any mammal that ever lived. Biomechanical analysis reveals bite forces that could shear through bone like scissors through paper, but the mechanism was unlike any other predator. Instead of elongated canines, Thylacoleo had evolved a pair of enlarged premolar teeth that functioned as organic bolt cutters. These dental shears could slice through the heaviest bones of a Diprotodon with surgical precision. The killing stroke came from its thumbs. Each front paw bore a massive retractable claw on a semi-opposable digit. A dew claw evolved into a disemboweling tool. Thylacoleo would drop onto its prey, grapple with these thumb claws, then deliver the killing bite that could sever a spine or crush a skull. It was an ambush predator built for overwhelming instant violence. The ecological implications were profound. Unlike the pursuit predators that dominated other continents, Thylacoleo created a landscape of perpetual paranoia. Every tree could harbor death. Every shadow could conceal a predator capable of ending a fight before it began. For the herbivores of Pleistocene Australia, vigilance wasn't enough. The environment itself had become weaponized. Encountering Thylacoleo in its prime habitat would feel like discovering that teddy bears had evolved into ninjas. The familiar had become lethal, and the lethal had become invisible until the moment it struck. Across the grasslands of ancient Australia, herds moved like living mountains. From a distance, Diprotodon optatum resembled the mega herbivores of other continents. Massive, social, built for processing tough vegetation. But approaching closer would reveal something deeply unsettling. These weren't elephants or rhinos. They were wombats. Wombats the size of family cars. Diprotodon stood 1.8 meters at the shoulder and stretched 3 meters from nose to tail. Its bulk approached 2,800 kilograms, making it the largest marsupial that ever lived, but its anatomy told a story of evolutionary improvisation. The skull showed enormous nasal openings, strong evidence for a fleshy, mobile snout or trunk used to strip leaves from branches. Its 2 massive upper incisors gave the species its name, 2 forward teeth, and grew continuously throughout life to compensate for the wear of processing fibrous vegetation. The bone beds at Lake Calabana preserve entire herds that perished together, revealing the social structure of these giants. Adults, juveniles, and infants died side by side, suggesting family groups that migrated together across the drying continent. Unlike the solitary wombats of today, Diprotodon lived in communities, following seasonal patterns between feeding grounds and water sources. Their feet tell a story of compromise. The pillar-like legs ended in broad inward-turned feet that gave them a distinctive pigeon-toed gait. These weren't the feet of a fast runner, they were the feet of an endurance walker, designed for covering vast distances at a steady pace across varied terrain. Trackways show they moved in single file, following established paths between feeding areas and waterholes. But the most unsettling aspect of Diprotodon was its evolutionary trajectory. Stable isotope analysis of their teeth reveals they were becoming increasingly specialized, adapting to process the tough, low-nutrition vegetation that dominated the drying continent. They were succeeding by becoming more dependent on a landscape that was itself becoming less reliable. These giants moved with purpose and intelligence, but they belonged to a completely different branch of the mammalian family tree. They were proof that given enough time and isolation, evolution could produce ecological equivalents that looked familiar from a distance, but revealed themselves as fundamentally alien upon closer inspection. Megalania prisca stretched at least 5.5 meters from snout to tail, with some estimates reaching 7 meters. At over 600 kilograms, it was a monitor lizard that had grown to the size of a saltwater crocodile. But unlike a crocodile, it lived entirely on land and could move with shocking speed across open ground. Megalania belonged to the varanid family, making it a close relative of modern monitor lizards, including the Komodo dragon. This relationship carried terrifying implications because all varanids possess venom glands in their lower jaws. Megalania's venom would have been a complex cocktail of anticoagulants and shock-inducing compounds, similar to, but potentially more potent than that of its modern relatives. A single bite could send a Diprotodon into circulatory collapse within minutes. The teeth were the stuff of nightmares, recurved, serrated blades designed for tearing flesh rather than crushing bone. Unlike a crocodile's conical teeth, Megalania's dental arsenal was built for slicing, allowing it to inflict massive wounds that would continue bleeding thanks to its anticoagulant venom. It didn't need to wrestle prey into submission. It could deliver a surgical strike and then follow at a safe distance while its victim weakened. Megalania occupied the apex predator niche across Australia's open habitats, from grasslands to woodlands. Its metabolism, like all reptiles, allowed it to survive on far less food than a mammalian predator of equivalent size, making it ideally suited for the resource-sparse landscapes of the drying continent. It could go weeks between meals, then gorge when opportunity presented itself. Encountering Megalania would violate every expectation about reptilian behavior. Modern lizards are often sluggish, predictable, and limited by their body temperature. But this was a lizard that had transcended those limitations through sheer size and sophistication. It was fast enough to run down prey, intelligent enough to hunt strategically, and venomous enough to kill with a single bite. The psychological impact would be profound. Humans have an evolved wariness of large predatory mammals, but Megalania represented something outside our ancestral experience, a reptilian intelligence operating in a 600-kilogram body with chemical weapons. It was nature's answer to the question of how terrifying a lizard could become if given enough time and evolutionary pressure. Not every giant in Pleistocene Australia was built like a tank or armed with venom. Some of the continent's most bizarre inhabitants were smaller specialists that filled ecological niches in ways that defy modern comprehension. These were the supporting cast members that made Australia's ecosystem feel completely alien. Creatures that looked familiar until you realized they operated by different biological rules entirely. Zyglosis hackidae was a monotreme the size of a sheep that challenged every assumption about egg-laying mammals. Modern echidnas are secretive, spiny creatures that root through leaf litter for insects, barely visible unless you know where to look. But their prehistoric relative was a giant that would have been impossible to ignore. At 1 meter long and 30 kilograms, it represented the peak of egg-laying mammal evolution on a continent ruled by marsupials. Its long beak could probe deep into termite mounds and rotten logs, while its powerful claws could tear apart wood to reach grubs buried inside. But Zyglosis was more than just a scaled-up echidna. It had evolved behaviors and adaptations that would have made it a dominant presence in forest ecosystems. Its size would have allowed it to access food sources unavailable to smaller animals, while its robust build suggests it was capable of more aggressive foraging behaviors than its modern relatives. The existence of such a large monotreme in the Pleistocene highlights Australia's evolutionary uniqueness. Monotremes are among the most primitive mammals, evolutionary relics that survived in Australia while being replaced elsewhere by more advanced mammalian groups. Yet in isolation, they had not just survived, but thrived and diversified. Zyglosis was living proof that in Australia, the ancient could coexist with the modern, and sometimes the ancient could grow to impressive sizes and fill important ecological roles. Genyornis newtoni stalked through the woodlands like a feathered demon from another world. This member of the Dromornithid family, the mihorungs, or demon ducks, stood over 2 meters tall and weighed up to 240 kilograms. Its massive, deep beak has puzzled scientists for decades because it combines features that seem contradictory in modern birds. The jaw structure shows adaptations for processing extremely tough materials, with muscle attachments that indicate crushing forces similar to those of bone-cracking hyenas. But the beak shape also suggests precision feeding capabilities. Was it a mega herbivore that could crush tough seed pods that no other animal could process? Was it a scavenger that could break into carcasses abandoned by other predators? Or was it an opportunistic predator capable of killing smaller prey with its powerful beak? Recent analysis suggests Genyornis was probably all of these things. Its robust build and powerful jaw apparatus made it an ecological generalist capable of exploiting whatever food sources were available in Australia's unpredictable climate. Unlike ostriches or emus, which are primarily herbivorous despite their size, Genyornis appears to have been a true omnivore, with the equipment necessary for processing both plant and animal materials. The behavior of these giants would have added layers of strangeness to any encounter with Australia's megafauna. Picture approaching a waterhole in Pleistocene Australia. Diprotodon herds drinking cautiously while Thylacoleo watched from nearby trees, but also sheep-sized echidnas rooting through fallen logs and giant flightless birds patrolling the margins with their powerful beaks ready to crack bones or crush skulls. Paleontology's Azael represented perhaps the strangest evolutionary experiment of all. Related to Diprotodon but built along completely different lines, this creature combined features that made it look like it had been assembled from parts of different animals. Roughly the size of a modern horse, it possessed powerful forelimbs armed with enormous compressed claws that looked more like scythes than digging tools. The skull showed extremely retracted nasal bones, providing near certain evidence of a substantial trunk or proboscis. Combined with a long, possibly prehensile tongue, this animal was equipped for highly specialized browsing behaviors. The claws weren't for digging in the traditional sense. They were for tearing bark from trees and ripping apart vegetation that other herbivores couldn't access. Paleontology was the Australian equivalent of a ground sloth or a giant anteater, but built from a completely different evolutionary toolkit. It represented marsupial evolution pushed to an extreme, creating solutions to ecological challenges that had never been tested anywhere else on Earth. These diverse body plans and feeding strategies created an ecosystem with no modern parallel. Every ecological niche was filled, but filled by animals that looked like they'd been designed by committee from completely different evolutionary playbooks. A forest containing giant echidnas, demon ducks, and trunk-bearing marsupials with scythe claws would have felt more like science fiction than natural history. The result was a landscape that challenged every expectation about how ecosystems should function. Predators, herbivores, and omnivores all followed different rules, used different tools, and employed different strategies than their counterparts on other continents. Australia had become a living demonstration of evolution's creative potential when freed from the constraints of competition with mainstream mammalian groups. These diverse body plans and feeding strategies created an ecosystem with no modern parallel. Every ecological niche was filled, but filled by animals that looked like they'd been designed by committee from completely different evolutionary playbooks. The result was a landscape that felt more like science fiction than natural history. Between 50,000 and 40,000 years ago, Australia's evolutionary experiment came to an abrupt end. The timing wasn't coincidental. After surviving millions of years of climate change, ice ages, and volcanic eruptions, the megafauna vanished within 10,000 years of humanity's arrival on the continent around 65,000 years ago. The evidence is written in eggshells and burned bone beds. At sites across Australia, layers of Genyornis newtoni eggshell fragments show a distinct pattern. Below the 50,000 year mark, the shells are intact, showing normal decomposition. Above that line, they're systematically fragmented and show clear signs of burning at temperatures consistent with human-controlled fires. Early Australians had discovered that a single Genyornis egg, the size of a cantaloupe, could feed a family for days. The megafauna faced a perfect storm. Climate change was already stressing the ecosystem, making water sources less predictable and vegetation communities less stable. Populations were likely fragmented and declining. But climate alone couldn't explain the synchronicity of extinction across such diverse species and habitats. Humans brought something unprecedented: cooperative intelligence operating with tool technology and fire management. The megafauna had evolved in complete isolation from highly social primates. They had no behavioral adaptations for dealing with coordinated hunting parties, projectile weapons, or systematic habitat modification through fire. The Aboriginal practice of fire stick farming transformed entire landscapes, creating a mosaic of burned and regenerating areas that favored different plant communities. While this ultimately created more productive hunting grounds, it eliminated the specialized habitats that many megafauna species required. Diprotodon, specialized for browsing specific vegetation types, couldn't adapt quickly enough to the rapidly changing plant communities. Thylacoleo, the apex mammalian predator, faced a different kind of pressure. As the large herbivores declined, the predators that depended on them followed in a cascading extinction. The most specialized species, those perfectly adapted to very specific ecological niches, proved the most vulnerable to rapid environmental change. The extinction wasn't gradual. Radiocarbon dating shows that most species vanished within a few thousand years, incredibly rapid by evolutionary standards. Australia transformed from a continent dominated by giants to one populated primarily by smaller, more generalized species that could adapt to human-modified landscapes. Walking across Australia 35,000 years ago would reveal a continent in ecological mourning. The great herds were gone. The tree-climbing predators had vanished. The monitor dragons no longer patrolled the grasslands. Evolution's strangest experiment had ended, leaving behind only bones and the scattered remnants of a world that had operated by completely different rules. What remained was a continent forever changed, carrying the ghost ecosystems of a biological alternative history that had proved both magnificent and, ultimately, fragile. The megafauna's extinction marked the end of Earth's last great evolutionary isolation experiment, and the beginning of a human-dominated world where such spectacular biological diversity could no longer develop in secluded safety. The bones at Naracoorte and Lake Calabana now serve as monuments to what evolution can create, given enough time and isolation. They're also sobering reminders of how quickly even the most successful adaptations can become evolutionary dead ends when the fundamental rules of the game suddenly change. Australia's megafauna weren't failures. They were masterpieces of evolutionary engineering, perfectly suited to their world until that world ceased to exist. Their extinction wasn't proof of inadequacy, but evidence of just how alien successful life can become when evolution is allowed to experiment without interruption. We lost not just individual species, but an entire alternative vision of how complex ecosystems could function. The Australia that early European explorers encountered was already a ghost of its former self, a continent still recovering from the end of its most spectacular evolutionary experiment.